This video is to show you how to make a regression on Excel. So also maybe a scatter plot that you could use with that. First thing you're going to want to do is enter this data in. So I would enter it, with actual details like this. I've done that already. If you want, you can pause the video and enter this yourself. This is some data about rainfall and yield of olives per tree that I got from a textbook. So here's the information that I've entered in. I might format a little bit better. I kind of like things when they're easier to read and yeah, something like that. But it's just a table of data. I'm not going to make it real fancy. In order to get the regression, there's a few things you might want to do besides just get the regression. One is to calculate the correlation coefficient. And in order to do that, it's equals CORREL, correl, parentheses, and I'm using a Mac, so it looks a little bit different on PC, but at some point it should pop up with here's what the command is. So array 1, that's your data, comma, array 2, that's your other data, and they should be the same size, same length lists, and close the parentheses, and then there's the correlation, which makes it seem like that's a fairly strong, positive, linear relationship. We'll see in a graph in a few minutes that that number doesn't tell you everything. You can also calculate like the R squared, which we'll see in a minute too. To get the linear model, the command that you want is LINEST, L-I-N-E-S-T. So I will type down here equals LINEST, that's linear estimator, parentheses. And what it asks for is the known y's. It wants the y's first, comma, then the known x's. Well, these are the y values because it's labeled conveniently y. And obviously, I hope obviously that it's the rain that tells you how many kilograms of olives you get, not the kilograms of olives that will tell you how much rain there is. Comma, here's the explanatory variable, close parentheses, and you're going to get two numbers here. If it's on a PC, you might get a warning or a notification that something is spilled over. On my Mac, it doesn't tell me that. I entered a command in this cell, but I got answers in two cells, and that's grayed there. It automatically filled in where it needed to. That's good. What you see here in order are the slope and the y-intercept of the model. You have to know that's what they are. It doesn't tell you that's what they are. And if you want to write that as an equation, you could say something like y equals 1.78-ish x plus 40.5. I'm using the 3 sig figs that exams like on IB tests. Another thing that's really helpful to do here is you can calculate things like maybe I wanted to make a prediction about some number that's not in the table. What if I have 19 centimeters of rainfall? What would the model predict? Well, these numbers are very helpful. So I think I'd say I want to make a square for my input. Do it inside input. So rainfall. And then the prediction of the yield. Dead yield. You'd think I'd maybe make a script for one of these at some point, but I never ever do. So the rainfall, let's suppose we want to do 19. That can be changed. I don't know a better way to do this. Well, anyway. The predicted yield is going to be a formula calculated with the slope and y-intercept. So to make the spreadsheet do the calculation, it's equals, and then it's the slope. So I'll click on that number times the input plus the y-intercept. I'm just interpreting this with that being my x value. When I hit enter, it'll calculate the predicted rainfall for me. Oh, sorry, predicted yield of olives for me. And if I change this to something else, like 12 or 9 or 23, then it will automatically update that. So the formula for that here was, click here, it'll highlight for you. It was the blue, that's the slope, times the input, that's the red here, plus the y-intercept, that's the purple. Another thing that's useful to do is to get a graph of this because the correlation coefficient is pretty high. That seems pretty linear. But when you select all the data and put in, by inserting a scatter plot, what you see is, there's a weird curvy thing. In fact, having your graphs overlay your text is really not good. So I'll move things around. Most of my information here is in the top upper, I don't know, third maybe of the graph. There's a whole lot of wasted space here. So something I might do is make this scale, like vertically, I don't really need to go down below about 40. So I'm going to change it. If I right click on the numbers here and choose format axis, format whatever, we'll bring up this thing on the right hand side. Format axis is what I want. I'll say that that minimum only goes down to 40 and look at it again. And yeah, it looks way less linear now. I might even on the left side here, click on this, only go down to 5 and spread that even more that direction. And we can see that it's really not quite so linear at all. It looks very, almost like a cubic equation, very strange. Maybe it's a quadratic that opens downwards. There's some optimum amount of rain. Less than that, you don't get enough. More than that, the tree is not healthy and it can't produce enough either. So looking at the picture before you decide, oh, it's a line, really good idea. Really good idea. But don't put the line on the picture until after you've looked at it and thought about it. In order to add the linear model here, if you right click out here, if you're using Windows, I think you get a choice to add a linear trend line, just add a trend line at this point. But what works all the time is if you click on the graph and then go, make this a little wider. Okay, sorry. There we go. If I click on the graph, in the chart design tab, the very left-hand thing is add chart element and trend line, and then linear, we'll add that on. You can see that line doesn't, it fits okay-ish, but there seems to be something else going on. There's patterns in the residuals if you're a stats person. To see the equation, click on the line, and over here on the right, one of these, it's that one, lets you display the equation on the chart. And so there's the same equation that I had here, only with fewer digits available. I can also turn on the r-squared. Let me go back to other line. And then here, display the r-squared. You can see the coefficient of determination. That is the square of the correlation coefficient. You can calculate the r-squared value separately. I can do this easily. Well, it is possible to get superscripts here, but it's making me work too hard for it. Way too hard. There. To get the r-squared value, the command is equals RSQ, I think. Yes, RSQ for r-squared. It asks for the known y's, comma, the known x's. So known y's, comma, known x's. Although the order shouldn't make any difference. And there you go, 0.7276 is the same number we saw there. Those are not the same thing. R-squared and correlation coefficient are two different things. Make sure that you know which one you need and which one you have found. I think that might be all I want to show about this one. So feel free to rewind and watch it again.